Good morning, Cisco Cohort 1. This session is being recorded and will be posted later today to the recorded presentation site. Speaking of said site, see if I can flip over here. Flip. Okay, I'll do it this way. Oh, because we were iced out last week, I made some recorded presentations. I put an announcement in here, but I just want to call your attention to the fact that I put together these last two presentations. The Chapter 5 PowerPoint presentation and the run through on the Lab 3443 packet tracer for last week's stuff that we missed. Okay, let's see, I need to stop sharing this and start sharing. Okay, two chapters to cover today. We're going to cover Chapter 6 on building a home network, and then we're going to cover Chapter 7 on some basic security stuff. So rolling right along, let's get one going here. So let's look at, in this Chapter 6, we're going to look at what home networks look like, a little bit about Wi-Fi and wireless networking, choosing an internet service provider, although I've already got the answer for this one. 99% of all my students that ever take a class from me use the cable company. The other 1% use the phone company. So I'm the odd man out. I use the phone company. Everyone else seems to use the cable company because they're a little bit faster. We'll look at some basic security considerations in home network and mobile devices. So home networks. It's a local area network, and remember our definition of local area network was a small network that was within the distance limitations of a local area network. Are usually constrained by the 328 feet of a twisted copper cable like a Cat5, Cat6 cable, or the distance limitations of a Wi-Fi network, which is a similar range. It's under the control of a company, or in your case, it's under the control of you, the residential user. You get to choose what equipment to buy. You get to choose what internet service provider to use and what home router to buy and things of that nature. So these devices typically have a internet port or a WAN port, wide area network port, that connects to your cable modem or your DSL modem. And then they have 4 Ethernet ports, which is the local area network, besides the built-in antennas, depending on what type of Wi-Fi system you have on that particular device. Some of the companies, both the phone company and the cable company in our area, are also offering, instead of a legacy, you get a home router from Linksys, and then you plug it to your cable modem. They're offering an integrated devices that combine, for example, the cable modem and the home router is combined into one enclosure. And it has the Wi-Fi, and has the 4 Ethernet connections. The service that I get from the AT&T, the Death Star, the telephone company, is a similar system. It's one box. It has the 4 Ethernet plugs. It has the built-in Wi-Fi. It has the very high bit rate DSL service, about 75, 80 megabit service that I get. I used to have the old DSL service, and it was about 5 megabit. It was really slow. Oh, it was really great when we first got it. That's 3 times the speed of a T1. That was really good for 1995. Wi-Fi, wireless technologies, we have 3 media is our term for the things that we use when we list the things that can carry the bits, the ones and the zeros, that carry information back and forth, eventually in the form of frames and packets and high-level information. So we can transmit bits of electricity over a twisted pair copper cable and come up with an agreed-upon method of what's a 1, what's a 0. We can shoot pulses of light through a fiber optic cable and agree as to what kind of light flash represents a 1 and what kind of light represents a 0. Or we can transmit through the air with radio waves, like television waves or radio waves, FM radio, or radio waves that spread through the air, electromagnetic radiation. So Wi-Fi uses electromagnetic radiation in various frequencies to send information between devices. Now with home Wi-Fi and business Wi-Fi, it's in the 2.4 gigahertz and 5 gigahertz frequency ranges. And typically what's implemented over this is something that's similar to Ethernet. It's a Wi-Fi kind of an Ethernet. It's slightly different technically from the twisted pair cable Ethernet or fiber optic version of Ethernet, but it's still the same sort of idea. We're going to use Ethernet, which is a data link layer technology, and create an Ethernet frame, and we're going to encapsulate an upper layer network packet like an IP packet containing upper layer information. So the home router takes care of all this interconnection between the WAN circuit to your cable company, your 4 Ethernet ports, whatever you're plugged into those. If those 4 are not enough, you can buy a switch for $10 or $15 and plug it in and extend the number of ports. And then the Wi-Fi system will connect all your Wi-Fi devices that you have at home. So he says, how does Wi-Fi work? Well, a bunch of smart guys stayed up late one night and came up with some standards for making this work. This whole idea of interoperability, open standards, which has not been around forever. Back in the early days of computing, up until the end of the 70s or so, 1970s or so, every different computer manufacturer had his own standards and protocols for communicating, and they just would not talk to each other. So if you had an IBM computer and another department had a Burroughs computer, they couldn't share information back and forth between each other. But the federal government stepped up in the late 70s and said, we need a way for these guys to interoperate with each other. And so they sort of forced the issue to take place. So the standard that's come up with, the IEEE is an international organization of electrical engineers. They have a standard, for example, they have a standard called 802.3 for regular Ethernet over wired sessions. Hang on a second. Two tenants. They have a standard 802.11 for the various forms of Wi-Fi. Now, Wi-Fi has been very popular for about 20 years. They started putting Wi-Fi devices in all the laptops, and it became very popular around 1988, 1999, 2000 timeframe. So they have some standards of things like what network mode are we going to be in? There are several different modes. We have a photograph here of the configuration screen from a home router, and it shows that the network mode is in the mixed mode, which means it's going to accept low frequency, the 2.4 gigahertz, high frequency, the 5 gigahertz. It'll accept all of those clients. You might have an older device that only has an older network connection in it. You could also put that switch in the mode where it would only accept low frequency or only accept high frequency devices. The network name itself, or the SSID, the identification number, is what you name your home network. The standard channel that it uses is, there's about 14 channels used in the domestic United States. He's set for channel 1. I think a better bet would be something like channel 7, which is in the middle, because these channels sort of overlap each other. And if you're on channel 7 and your neighbor's on channel 6, there could be some interference between them. The SSID broadcast is a feature that's on by default. And what it will do is when you create a Wi-Fi hotspot, like with the home router or with a telephone that's got the hotspot feature, it will broadcast out, in this case, the name Cisco. So when someone else goes into their Wi-Fi configuration setup on their device, they're looking for a Wi-Fi network to join, they'll see Cisco listed in there, or whatever name you use, your particular one. It is possible to turn that off if you don't want to broadcast it. That's not good security. It's very easy to find you, even if you don't broadcast that SSID name. So we haven't talked that much about how standard Ethernet works. Standard Ethernet has a standard Ethernet has a feature that whenever an Ethernet, like a desktop PC that's plugged into the wired Ethernet, wants to transmit something, he's supposed to listen to the cable and see if anybody else is sending their traffic at the same time, and he'll wait for them to be done. And then he'll transmit the traffic. And if 2 or more host machines on a wired Ethernet network just happen to start transmitting at exactly the same time, they'll both back off and they'll retransmit their data after a programmed random timer, so that they won't collide with each other again. Well, Wi-Fi is a little bit more delicate. Wi-Fi has got a bunch of different devices sharing the same frequency spectrum, and so they use an additional method to try to reduce collisions. And I'm going to say again, a collision is what happens when two or more devices try to transmit their bits at the same time. Only one device is allowed to transmit at the same time. Think of CB radio channel 19, okay? And you're listening on your CB radio channel 19, and everybody's transmitting at the same time, and it's complete garbage. So with Ethernet, we've come up with a scheme for reducing these collisions, because if I transmit my ones and zeros and you transmit your ones and zeros at the same moment, well, in binary, there's only zeros and ones. The voltage, some voltage represents a 0, some voltage represents a 1. If two people transmit at the same time, this adds up to a voltage level representing 2 and 3. Well, in binary, there is no 2 and 3. There's only zeros and ones. So that's how they can tell a collision has occurred. They start hearing the binary levels, non-binary 2s and 3s, and they know a collision has occurred, and they need to stop and try again. So Wi-Fi uses a method that they stole from AppleTalk, which is called carrier sense multiple access collision avoidance, instead of their standard carrier sense multiple access collision detection. It's what standard Ethernet wired uses. So what Wi-Fi does is, if they intend to transmit something, they sort of like push the talk button on their mic down and say, "Stand by, I intend to transmit," and then they stop. So this is sent as a means of identifying all the other workstations that may have also had something they wanted to send, to back off and wait for that first station. He sort of reserved the channel. And so they send a little ping-like message that says, "I intend to transmit," and then they send their information, but they're still checking for collisions because someone else could have not heard it and transmit at the same time. So let's set up our wireless network. Hang this 1 second. 1, 2, 3, 4, 5. Okay, good. So many wireless routers, particularly if you're a cable customer, you can generally just plug your Linksys router into the cable modem, and it'll just start working. If you were the old telephone company DSL, you had to put in a name and a password. It wouldn't just start working. So generally speaking, right out of the box, they'll just start working perfectly automatically. If you don't have the Linksys type separate router, home router, you get something from your cable company, they will pre-configure it for you. So he says that if SSID broadcasting is on, that's the thing that automatically sends the name. It was the name of Cisco in that previous screen. Anybody that's a wireless client that wants to connect will be able to see someone has a Wi-Fi access point, and its name is Cisco. Now, how do I keep people from using my system that aren't in my family? Next door neighbors or something, and they're within range and they can hear it. So what you can do is, in this case, the screenshot is showing that we have looked at the MAC address is like a hardware physical built-in address. Remember we did that lab, we did ipconfig/all, and it gave us that hexadecimal representation of our 48-bit binary MAC address, physical address, burn-in address. You can key into the chart in the configuration screen of your home router which MAC addresses are allowed, and you'll put in the MAC addresses of your devices. And then on the right-hand side of this chart here, the guy with the X, he's your neighbor. He's across the street or something. He's going to try to get free internet service from you. So his MAC address is not recognized as a valid address. It will be filtered. So he wouldn't be able to use your connection. That's one way of doing that. We're going to look at there's a password method too. Okay, internet service providers are the people that you typically the cable company or the phone company if you're residents. If you're a business or commercial enterprise, there are some other big players that have more expensive connections. So we're in the $50 a month range for residential internet access. The exact same speed to a commercial user would be $1,000 a month. That's because they have much more reliability, higher standards, and guarantees, service guarantees that you don't get from the cable company. You just get best effort. You don't get quality of service from them. So the internet service provider is connected to all the other networks that form the internet. And oh, wow, this slideshow is chopping off the words here. So we would need a router connect our computer to an ISP. So you would get a Linksys style home router, or maybe the later generation of telephone company and cable companies is a single integrated device. They give you that option. So it's the Wi-Fi, the Ethernet connections, the DSL modem for the phone company or the cable modem for the cable company. It's all built in the box, and they control it. Then you can go into a menu. You can set up your security. You can do your MAC address filtering or your Wi-Fi passwords. Okay, so DSL and cable. DSL is an old technology that was the first kind when internet service first became available in the Dallas-Fort Worth area. The only way you could get, besides the old dial-up screeching cats modems, they're real slow. The first high speed, over a megabit of speed, was from the cable companies and the DSL telephone company providers. So back in the late 90s, I got a whatever the name of the cable company in Fort Worth was at that time, Charter, I forget what it was. They offered a thing called At-Home Network, and it was about 4 megabit, and this was sent over the cable company wires. The telephone companies soon also offered their DSL, which is a method of sending both the old analog voice conversation and a newer modulation method of digital signals over one existing telephone line. That might be real old. Another method is cellular phones. Many cellular phones are, if you have a cellular phone today, it's IPv6 based. And many cellular phones, of course, have web browsers in them, or you can turn them into a hotspot and have a desktop computer or laptop computer nearby connect to your cellular phone. Satellite service is also available as it's usually the most expensive and the slowest, but in areas where you just can't get, let's see, time for Mark to rant. Rant mode on. The cable companies and the telephone companies only provide service in areas where there are lots of people and they can make big profits. So if you're someplace like on the west end of Galveston Island or in the middle of the desert in Arizona, there's not going to be a DSL wire there. There's not going to be a cable company system there. But you can get like Hughes Satellite, which uses the geosynchronous satellites, and you can connect to that, and it's a little bit slower and it's a little bit more expensive, but it's an alternative that you could use. And then at the bottom, we have a regular dial-up telephone. If you have a regular dial-up telephone line, you can use the old Hayes type modems. I call them the screeching cats modems because they make that screeching cats noise when they first connect, but it's very slow. But telephone service, dial-up telephone service is available in most areas. Okay, let's look a little bit at security. We're going to get more security in the next chapter, but let's look at it now. So Wi-Fi is transmitted information, just like FM radio stations. You can tune into it, listen to it. You can turn off the SSID. That means someone has to know the ID. That's not a very good measure. Can we tell who the hacker is in this picture? Oh yeah, it's the guy with the black hat on. So this is like, in the Westerns, we always know who the bad guy is. He's wearing a black hat. We always know who the good guy is. He's wearing a white hat. If only the hackers and the good guys could be distinguished in real life in computer security the same way. So we use our diagram here of the black hat guy. He's our malicious intruder. He's our threat actor. He's going to try to break into the system. Most devices have a default password. Linksys devices, for example, you can log in with the password admin and get right in. If no one ever changes, you get access to that particular device. So we're going to use several different methods. We can turn on SSID broadcast, which is a weak defense. We can change the default settings. So we can use, like the previous slide, we can use MAC address filtering. We can also set a Wi-Fi password. And don't use the old WEP, wireless encryption privacy. I call it weak encryption privacy. Use a WPA. That's a much stronger encryption method. And that will be a password that would be more difficult to crack, but it's not impossible for a determined attacker to get in there, or a state agency, you know, like the National Security Agency or the CIA. They could probably crack it if they wanted to. So let's authenticate users. We want to allow you to get connection to the network based upon some type of authentication. So for example, it's not shown in the slide here, but when I connect to my telephone company AT&T system, they've set up a name and password that authenticates me onto the network. The old DSL was the same way. It had a particular name and a password that you would key into your home router, and then it would connect to your account and give you internet service. You can also set authentication by simply using something that you are, your MAC address. I'll get to this more in the next chapter, but there's 3 types of security. Something you know, like a password. Something you are, like fingerprint, eye retinal pattern. And something you have, like an ATM card with a MAC strip on it. So in this case, the laptop computer on the left, it says, this is something I am. I have this MAC address. And so the MAC address, again, is like your social security number. It's fixed to you, and it never changes, typically, for the rest of your life. And then on the right, the home router has checked that MAC address list and says, oh, you're on the approved list. You're not someone across the street who's trying to connect. And then the 2 devices will connect to each other. They'll exchange some keys, some security keys, and then you'll be able to associate with that Wi-Fi point and be able to use the internet. That takes place in the twinkling of an eye. So WPA, Wi-Fi Protected Access, is the current recommended method to connect to a home router. So this uses encryption keys. Encryption keys are binary patterns, usually based upon prime numbers. The more bits, the safer they are. In other words, if you use more bits for an encryption key, it takes longer. They can be broken. Any determined hacker can break them. But if you have more bits, it would take them a longer time to do it. Like it might take them a couple of years of processing power on a desktop PC to break it. Whereas if it was a fewer number of bits, it might be broken in 5 minutes. The old weak encryption privacy, it's called wireless encryption privacy. I call it weak encryption privacy. It uses the same key every time. But the WPA generates new unique keys every time. So that means if a hacker breaks a key one time, it won't work the next time. So it's more secure. So let's use some security measures. Let's change the default value for the SSID. It's maybe Linksys for a Linksys home router. If there's any passwords and usernames that are set for the administrative account, which by default on a Linksys router is the password admin, let's change those to something else. Turn off the broadcast SSID so people just can't see you there. And we can turn on MAC address filtering and key in the MAC addresses of all our authorized devices that our family is using to go in there. We can use more sophisticated techniques. We can use WPA2 and turn on encryption so that nobody can see our data that we're transmitting. Like, say you take your laptop to a Starbucks coffee shop and you don't use encryption. Anybody else can run a program called Wireshark and see all your data. But if you encrypt it, it's very difficult for them to see it. Configuring authentication is proving who you are, who you say you are, by knowing a name and a password. So names and passwords and things of that nature. Something you know, something you have, something you are. And then we can do traffic filtering, like with Wi-Fi addresses. Security is like layers of an onion. We're going to do as many things as possible. And if an attacker breaches one layer of the onion, several more layers of the onion are there to try to prevent it from actually getting to the goodies. So security measures typically are several different measures. So let's do MAC address filtering. Let's use WPA2 passwords. Let's turn off our SSID and create several layers of security here that would, the attackers say, like, the burglar is going to try to break into your house. You've got a very secure lock and you've got cameras. The guy next door to you, he's got a crummy lock he got from the Home Depot. He has no cameras, and he's going to be more easy to break into. He's going to go for the easier target. You want to make yourself a hardened target so you're more difficult to break into. Now, he's talking about some precautions. Never send a login or password information using unencrypted text. So if you come to Tarrant County College and you join our free Wi-Fi network, it is not encrypted. It is plain text. Anyone could use Wireshark and see stuff that you're transmitting over that. Now, you could turn on a VPN connection on your laptop so no one could see it. You could do the same thing when you go to the coffee shop and use their free Wi-Fi. It's not encrypted. But you can use a VPN connection which encrypts the data before it ever leaves your computer. And if they don't have the key, they can't see this. So we should enable security on home networks and use the strongest protection that they offer. Windows devices are very good about connecting to a strongly encrypted home router. They'll put up a little screen when you click on that SSID, the name of your home router, and then they'll ask you to key in the security key. And you key that in one time, and you'll know it because you did it on the router. And then they'll connect to this. Says when a mobile device is out of the range of the Wi-Fi network, it could try to connect to another Wi-Fi network. If no Wi-Fi networks are available, then a mobile phone would use the cellular data connection instead, and you typically have minutes or gigabits of bandwidth that you got with that. Now, Bluetooth is another method that's similar to Wi-Fi, uses the same frequencies, 2.5 to 5 gigahertz, 2.4 and 5 gigahertz. It's intended to be what's called a PAN, a personal area network. It's intended to be used like with the, you've seen the people running around with the headphones, the little one-piece headphones, and they're connected to their phone so they can talk and have a phone conversation hands-free. They can keep the phone in their pocket or whatever. It's a wireless system, kind of like Wi-Fi, and it's a very low power. So you can have a little tiny hearing aid battery in these Bluetooth headsets, and they'll last for a very long time. Okay, let's stop using this. And let's start using the second PowerPoint presentation. Okay, can you see that? Yeah, I can see that. Oh, what happened to my other screen here? Okay, now we're going a little more into introduction to security here. So we're going to look at threats. We're going to look at attack methods. What can you do to protect your network? What can you do to mitigate? What does mitigate mean? When you buy car insurance, you're mitigating the financial risk to you if you hit somebody else's car. They'll pay off the other guy's car. You might need to pay a deductible. So in network security, we're trying to mitigate risk so that, there's going to be no protection. If a determined North Korean attacker wants to break into my network like they did into Sony or whatever, I can't stop that. But I can mitigate it by putting as much protection methods in there, backing up on my data so that if they do the ransomware, I can still be able to keep my business in operation. And then we'll look at what firewalls do. So why would a hacker want to break into someone's system? Home users, they're typically not that much interested in because they can't pick their pocket with a ransomware type attack. They don't have data that has any type of value. But in a small business or any large type of business, we're looking at theft of information, identity theft. How about loss of data or manipulation of data or disrupting service? So in education, we have some federal laws. We have something called FERPA, the Family Privacy Act. And it's a violation of the law for us to let somebody else know, say, what your social security number is, or anything else beyond directory information. In education, what we call directory information is your first and last name and what classes you're enrolled in, and if you play on a sports team, not much else. We're not supposed to let other information get out. How about if you applied for financial aid? You think everybody else should be able to learn, your income tax, financial records and stuff like that? No, they shouldn't be able to do this. In industry and outside industry, we have similar methods. So in the medical field, we've got you can't release medical information without permission of the patient. In the business world, we have Sarbanes-Oxley. We can't let information get out. So a big threat to these days in business is a malicious user, a threat actor, will break into a business system and he'll monitor it for maybe a month or two and figure out where the good servers are with the good information on them and how they back stuff up. And then they're going to make copies of everything on that target company's network. And then one day they're going to drop the bomb. They're going to encrypt all the data on every computer that company owns, including their backups, and say, you must pay me $500,000 ransomware. And if you don't do it in a week's time, it's going to go up to $1 million. And if you don't pay it within 2 weeks, we're going to release all this information that was on your private company network, including these files, which you get in trouble with the federal government because it's information that's supposed to be protected. So it's very much a money thing. They're trying to get ransom from you to do this. And they're being very successful in this because many companies aren't well defended. Social engineering is a technique where someone will call you on the phone and they'll pretend to be, they're actually an outside person trying to break into your system. They're going to call somebody and they're going to say, hey, this is Fred from the network engineering department. We did that collision domain upgrade on your network, and what was your password so I can make sure that worked okay? And most people just want to be helpful and they would give their password. We have to educate our employees and our users. You don't ever give your name and password to anybody for any reason. If your boss calls and wants your name and your password, you don't give it to them. If your boss needs to see your files, he'll notify the IT department and they'll give him access to your file shares. So this is pre-texting. We call on the phone and people will just want to be helpful and they give me some information and that allows me to break into the system. Phishing and vishing are when we send you an email and try to do the same thing. So Tarrant County College is in the process of running some phishing tests on all the employees here. We got about 2,500 employees. Oh, we just got an award. Tarrant County College just got an award from Forbes magazine. We're one of the best small to medium-sized businesses to work for. We're in the top 100 list. Yeah, with a bunch of other companies. Pretty neat, huh? So if you send a phishing mail, it might say it might look that it's coming from the Human Resources Department. It says, click here to verify your vacation time, and we have to change your password to do this. Put in your current password. But it's not really from the Human Resources Department. It's from some outside group that's trying to break into your network. Now, if they can take over your account, then they can try that as leverage and try to force access to more important things like student social security numbers, financial aid records, things of that nature that they could do a ransomware attack against. Okay, so here's some other types of attacks. Virus, program that spreads by modifying other programs and files. It gets into your computer and it modifies a program that your computer normally legitimately uses, but it puts some extra stuff on it so it can spread and go to the network and do stuff like that. Modifies other programs and files. A worm is kind of like a virus, but it spreads through the network. It goes out through the network wiring, and so if you can be seduced into clicking on that phishing link and you put in your password, and the outside user from the Ukraine or whatever, who's a malicious user, gets a hold of your account and then uses that to try to, like a cancer, he's going to metastasize into the whole rest of the company network until he finds the valuable servers and take them over. A worm's like that, it spreads to the network. A Trojan horse is a program that looks like it's a useful program or attractive program of some sort, but it's really an attack program. So a program like, for example, might say, look at this cool video about the dancing babies. And you run the program and the dancing babies video plays on the screen. And while the dancing babies video is playing, it's encrypting all your files. And then when you finish the video's over, that's it. You get the warning message on the screen. You have to pay the ransom. So some methods of attack. Denial of service, brute force. What is this? So a denial of service attack. Now we haven't talked much about the transport layer. The transport layer is the layer where TCP and UDP use that. And TCP uses a thing called he makes a connection between the server computer you're trying to get his website from and your client computer to make sure they're both free and available to connect to each other. And a malicious user can send the first part of this handshaking request, but never respond to it, and then use 50,000 of his friends he's taken over with on a chat channel. And so they've got I don't know if you've heard the term, a hacktivist is a hacker that has he's got some sort of political aim. So a hacktivist says, I think that Bezos the Beast is making too much money in Amazon, and we're going to shut down Amazon today. And we're going to do a denial of service attack against Amazon so they can't take their millions of dollars of orders every second and make a big profit today. So they'll do this TCP sync act, half handshaking thing and try to take down the Amazon server. Or this ping program. that we use to test connectivity? What if I send a continuous series of super duper on steroids, heavy duty pings, and your server is so busy answering the pings, he can't respond to his legitimate work, and the employees can't get to it? Distributed denial of service attack is the previous denial of service. I was one guy and I sent the pings over and over again, but I'm just one guy. Amazon servers are probably, you know, they can take 50,000 simultaneous connections with no problem. So I'm going to go into the chat channel and take about 100,000 home users that I've zombified their machines. I've taken them over, and I'm going to issue a special chat command and have them send 100,000 denial of service attacks to the Amazon server, and that might make him fall down and stumble. So we want to overwhelm saturated network links with useless data. Brute force is a technique that before I get access to your system, I need to know what your password is. I have no idea what your password is. Well, what if I just tried every possible password you could type in? So I'll use a really fast computer, and I'll try to send lots of different possible combinations of passwords that you could use. And if I can do this quickly enough, eventually I'm going to hit a password that's okay. So in network security, we try to defend these things by, say, restricting, if you get 3 passwords wrong in a row, he's going to lock your system out, and you'll need to reset your password to try to prevent brute force attacks. Okay, a spyware is a program that maybe you clicked on a dubious link on a dubious website, and it installs something on your web browser that tries to gain information about, what type of advertisements are you looking for? It can even include passwords and things of that nature. So a spyware program is going to try to make this information available to, it's not as bad as adware. Adware is, you can always tell the people that got a bunch of adware because their websites are completely clogged up with all these browser add-ins. It's taking up a whole screen. So you need to get malware bytes or something like that and clean your system off to get rid of that stuff. Okay, I talked about the zombification before. What we can do is we can do a spyware on a bunch of home users and take over their computer, but not so much that it bothers them or they notice it. But when I get ready to, remember, I'm the hacktivist. I hate Bezos the Beast. I want to take Amazon down. So I'm going to take over 50,000, 100,000 home computers that I've infected with spyware and say, send a bunch of fake ping, send a bunch of TCP, sync, ACK, half handshaking requests, send a bunch of spam email, and overwhelm these people. And that's called a botnet, when I zombify a bunch of things and take them over. What's your best defense against this type of thing? You can put, well, we're going to talk about this in a minute. Antivirus software, things of that nature. Okay, Microsoft and pretty much Macintosh, Linux, pretty much all the operating systems that are in common use today they've implemented features that will automatically update the operating system. If a bug is found and the manufacturer finds out about it, the software vendor finds out about it, he'll fix the bug, he'll redo the code to remove the bug, the vulnerability. So if you're using Microsoft Windows, for example, out of the box, he'll automatically update himself. You don't have to click updates and look for it. He'll do it automatically for you. So we want to keep our operating systems up to date. And then we can use some security tools as well to try to prevent security problems from bothering our systems. So patches, here's good old Windows. Probably 95% of desktop users are using Windows, Microsoft Windows, the desktop client operating system, as opposed to the server operating system. So Microsoft can issue a patch. They're going to take the lines of code, and there's like 100 million lines of code in Windows. Okay, so it's real hard when you have that many lines of code to have no problems. But they find a problem that was discovered, and they change the code slightly to alleviate that problem. So a patch would fix that problem, and an update may include like additional functionality that users can use. So Microsoft and the other vendors are they're very upfront with this and aggressive with this because they don't want technical news websites to talk about how Microsoft computers had vulnerability that didn't get fixed and a bunch of people lost their data. Antivirus software is if some type of virus gets on your machine, you may look at the blue screen of death we got here. Oh dear, obviously something's wrong with this computer. The computer has started acting abnormally. Or if the computer's still running, it's real slow. Or your email program just starts sending out weird emails and you didn't click the send button. The CPU is getting hot and the fan's running real high all the time. The computer can crash or slow down. So how can we tell if it's been infected? We can use an antivirus software and install it on the PC, and it'll look for all the known viruses that are out there. And there's lots of them out there, and they've all been found. Well, someone writes new ones every week, and they'll be found, and they'll be put in the next version of the antivirus software signature file, which if you buy an antivirus program, it will update itself automatically. Microsoft has a very good one called Microsoft Windows Defender. It comes for free with Windows, and it automatically updates itself. And there are other commercial programs you can pay for and get more advanced features, but most of the commercial antivirus programs offer a free version that does just basic antivirus software. Anti-spam software is, hang loose, we have a user that's joined us. Anti-spam software looks for things like, well, for example, I have my Microsoft Windows mail account that we give the employees here is set so that if it finds something that's spam, it'll put it in a spam folder. If you're using Google Gmail or Yahoo Mail or the Microsoft email program, they offer these similar things. It'll try to detect spam and put it in the spam folder for you. Everybody wants to forward stuff. They get something and forward it to everybody they know, but it might be not a real threat. So don't bother forwarding stuff. Everyone's going to find out about it. Their antivirus program will tell them anyway. And you can go to a reputable site that reports on real problems with spam and viruses and stuff like this. So if you install a piece of software on it that will detect and remove these spywares, these adwares, pop-up blockers, you can get a program. He's showing a program here called spybot Search and Destroy. It's one program. You can get it for free. Install it on your PC, and it'll scan all your web programs and all your files on your PC to look for anything that's been installed on your PC that shouldn't be there. And even if your PC is performing normally and seems fast, you should get something like this for free and run it every now and then to check to make sure nothing's wrong with your machine. Okay, now firewalls. In a big company, we have a firewall appliance. It's a box. It's this brick oven thing here in the picture that sits between the company network and the world. And according to the wishes of upper management of the company, they had decided what type of traffic is to be allowed onto our internal network and what is not to be allowed. Now, they're not technicians. They can't write iOS code, but they tell the IT department what is to be allowed, and the IT department implements whatever upper management tells them to do. So, for example, a company might decide that we're going to allow those two green arrows going to the server at the company. One of them is authorized web traffic, port 80. One of them is authorized email traffic, so we can get marketing requests, orders from our customers, port 25. We're not going to allow Telnet or FTP. These are unencrypted and they're not safe to use on the internet. So those two orange lines that are being deflected away from the world, those will not be allowed on our internal network. So we can use a hardware firewall as a freestanding unit to do this. And this is something that's sort of built into, most home routers have a firewall feature. They use network address translation to sort of hide your real address from the outside world. That gives you some measure of protection. And they look for things like a request coming back that you didn't ask for. They'll deflect that. They won't allow that to go through. But big companies use a dedicated firewall appliance, which can range in cost to, it's not unusual for them to be $50,000. Cisco makes some small ones that are only a couple $1,000s for a small network with 100 people. And these are crucial to protecting your internal network because you don't want to get the ransomware installed on your PCs and you're knocked out of business and then you have to pay money to get your data back because you're subject to federal law. The demilitarized zone is an area that both outside users and inside users can get to. So typically, as a security measure, we're going to partition our internal network into an internal trusted network. So when you come to the lab on Wednesday and you use that desktop PC in the lab, that's our internal trusted network. Our Wi-Fi network, our Wi-Fi access point that's on the ceiling, it's a sort of a DMZ. It's an external untrusted network because anybody could bring in any Wi-Fi device from the entire, we're open to the entire community. Anybody could bring in an affected device. We don't want it messing with our internal network. So companies will typically place their web server that serves up the web pages they want their customers to see in the DMZ, and they're going to really harden it up. They're going to make what's called a bastion server out of it, so it's very rugged and difficult to break into. It's not going to have any type of direct connection to the internal company network. So we can do this with a wireless router. We can set up an internal server that can be accessed by outside hosts. So port forwarding is a feature that you gamers are going to know something about this. This is a feature that I want to take I'm running some website that you're flying F-15s and you're doing air battles, but they need direct access to a certain port on my internal computer inside my home network. Well, we're not allowing anything but port 80. So we can manually map a port number to this outside service, and then we can run our game. So we can do port forwarding and port triggering so that only a particular port that we set up in advance can be used for this. And we can turn it off if it turns out to be a problem. Okay, I'm going to hang loose. Hold on, let me stop the recording.